Good morning everybody. Today's lecture is on numerical problems related to IC engine combustion. So, IC engine combustion we are talking about, then you need air plus oxygen, air plus fuel, air plus fuel. Okay. So, air means oxygen plus nitrogen. If other components are there, for example, a small amount of carbon dioxide or what moisture, H2O, CO2, H2O or some other component. So, we are ignoring that one. For our calculation purpose, we will assume that air is containing only oxygen and nitrogen. Okay. Normally, air intake will be happening at normal air temperature and fuel will be injected separately or will be mixed by carburetor, and combustion will be happening inside cylinder. So, inside cylinder you may need one spark plug maybe, or you can compress CI engine, only compression will be happening and fuel will be burning. So, that is the phenomena. Now, if we have very high amount of air, then what will happen? Fuel plus air, it is producing CO2 plus H2O plus maybe some other component. If you have higher amount of air means you have O2 plus N2. So, N2 is not giving you energy, O2 is giving energy, right, because O2 will be reacting with fuel and fuel will be releasing the heat. Now, excess energy, what will happen? This burn gas, when it is going out, exhaust gas, so the burn gas will have lots of air, oxygen plus nitrogen. So, because this oxygen plus air, excess oxygen plus air, it will be taking lots of heat, it will be heated up and it will be going out. So, actually it is not giving any energy, rather it is taking away your heat. Okay. And if you have less amount of air, what will happen? If you have less amount of air, so in that case maybe hydrocarbon, fuel means hydrocarbon, right? So, this hydrocarbon will be in your product or maybe carbon monoxide. So, hydrocarbon means your fuel is not burned completely, so you are not getting complete value of money. So, whatever you invested for fuel, so same thing is not burning, so you are not getting all the energy. But if you have carbon monoxide, again you are not getting complete combustion, means carbon is not producing carbon dioxide. Okay. So, in that case this carbon monoxide is harmful. Carbon monoxide production means you are harming your environment. Again you are not getting enough energy because it is not burnt completely. So, in that case again it will be negative for your engine. So, you cannot give very high amount of oxygen or very less amount of oxygen, you have to give proper amount of oxygen. The term is called stoichiometric ratio or air fuel ratio. So, exact amount of oxygen or air and fuel ratio, that is called stoichiometric ratio. And if you are giving excess amount of air, then you have to calculate accordingly. If you are giving less amount of air, again you have to calculate accordingly. But your target should be to produce not to produce carbon monoxide. Some amount of fuel oxygen is there in your combustion product, is still fine, but carbon monoxide and hydrocarbon in your fuel after post combustion, that burnt gas is still having carbon monoxide or hydrocarbon, it is not beneficial for your engine or for your environment or for your pocket. So, a chemical reaction may be defined as the rearrangement of atoms. So, atoms are becoming rearranged. For example, CH4 plus O2, it will be creating CO2. I am not balancing this equation, plus H2O. Okay. So, just you are rearranging the atoms. Okay, you are creating new molecule, and this is called reaction. Sometimes we say combustion or reaction. A chemical fuel is a substance which releases heat energy on combustion. So, here when combustion is happening, you are producing lots of heat. Okay. So, this is exothermic reaction. Exothermic reaction. Okay. Now, total number of atoms in each element concerned in the combustion remains constant, but the atoms are rearranged into groups. So, atoms will not be destroyed. So, same number of atoms will be there, but it will be rearranged. So, CH4 was there, it will be CO2 plus H2O, when oxygen also will be required for burning CH4. Similarly, you are rearranging the atoms. The amount of excess air applied varies with the type of fuel. It may 100% for modern practical engine, but 25 to 50% excess air is okay. Why excess air is okay? Because our target is not to produce carbon monoxide or not to give unburnt hydrocarbon in your exhaust gas. So we give some extra amount of oxygen so that all fuel will be burnt and you will get sufficient enough power for your engine. The stoichiometric ratio or chemically correct air fuel ratio is defined as stoichiometric air plus fuel ratio. So exact amount of ratio, exact amount. Okay, you are not giving extra air or less air. So mixture strength is called stoichiometric air fuel ratio divided actual air fuel ratio. What happens? Stoichiometric air fuel ratio is say 14.7. Okay, this ratio, but actually maybe you will be giving little bit less or higher. So that's called actual fuel air fuel ratio. So the ratio of stoichiometric divided by you are giving actual amount, that is called mixture strength. And the content I have taken from the book R.K. Rajput, Lakshmi publication. You should get this book in the library. Higher heating value for constant pressure is equals lower heating value plus mass of water plus HFG. So HHV constant, okay, HHV constant pressure equals LHV constant pressure plus MHFG. HFG means latent heat. Okay, previously I have discussed about that calorific value. So higher heating value means total amount of heat is there in the fuel, and lower heating value means higher total amount of heat there and how much amount of water it is producing or it is having water particle in the fuel. So that will be evaporated and it will take lots of latent heat. So that latent heat we cannot get back. So that is a loss, actually energy loss. So whenever you will be calculating or you will get power because of this lower heating value. Okay, so higher heating value if it is given, then and mass of water is given, then you can get lower heating value at constant pressure. HFG equals latent heat or enthalpy of evaporation. Enthalpy. Okay, enthalpy is also energy, internal energy. And if you know internal energy of gas and fuel, then it will be like this: HHV for okay, HHV equals constant volume LHV this okay plus M UG minus UF. UG means gas internal energy, UF means fluid internal energy. So if you can minus this one, so how much energy is there in gas, how much energy is there in fuel, so the minus actually it is HFG. Okay, specific internal energy of a liquid. This is specific internal energy. Specific internal energy of liquid, LIQID. Okay, and this is gas, specific internal energy of gas. So lower heating value plus this amount of energy will be lost. Okay, so equal that if you make total lower heating value plus energy loss, that will be higher heating value. In a given combustion process that takes place adiabatically and with no work or change in kinetic energy or potential energy involved, the temperature of the products is referred as a adiabatic flame temperature. Okay, for a given fuel and given pressure and temperature of the reactant, the maximum adiabatic flame temperature that can be achieved is with a stoichiometric mixture. Okay, now we have to see some problems. Now we will see some problems based on your amount of theoretical or practical air or fuel required to burn a fuel amount now see the amount of oxygen or air is required to burn certain amount of fuel completely. So we will try to calculate stoichiometry ratio or stoichiometric ratio, and we will try to calculate heating values also. So how to solve this one? First you have to write down the equation C2H2 plus XO2 A CO2 plus B H2O, because you don't know initially the balanced equation. For we are assuming that you don't know, we may be knowing, but if you have bigger long chain hydrocarbon, for example this C2H2, maybe C10 H20 or 22 will be there. So in that case your balancing will be very difficult just to calculate using mental calculation. In that case you can use the formula X, Y, A, B you can put and you can calculate that one. So here you can first you balance the carbon. So 2 carbon I have, okay, 2C equals AC. Then this is giving A equals 2. Now balancing hydrogen, 2H equals 2BH. You can see this BH. So this is giving B equals 1. So now the equation is C2H2 plus XO2 plus, not plus, this is equal sign, 2CO2 plus H2O. Now O2 calculation. O2, how many O2s are there? So 2x equals carbon 2. Now 2x equals 2 O2. O2 into 2 and plus H2O, 1 O is there. So therefore x equals 5 by 2, 2.5. Now the equation becomes C2H2 plus 2.5 O2 plus not plus, this is equal sign, again I am doing mistake, 2 CO2 plus H2O. Okay. Now this is having oxygen you are getting from air. So air will have nitrogen also. So now total amount of nitrogen, how much you are adding? Okay. Now from there you are getting C2H2 plus 2.5 O2 plus 2.5, 79 by 21 nitrogen implies 2 CO2 plus H2O plus 2.5, 79 by 21 N2. Why 79 by 21? 79% nitrogen by volume is there in air and 21% oxygen by volume is there in air. Okay. So this is mole ratio. So like for example 1 mole of ethylene is reacting with 2.5 mole of oxygen. So how many moles of nitrogen should be there in the air when we are sucking air? So air is giving oxygen plus nitrogen. So 2.5 amount of oxygen when you are sucking. So how much amount of nitrogen also you are sucking for your combustion? So that calculation you have to do first. Okay. So right side nitrogen is not doing any reaction. So right side nitrogen will be as it is. So 2.5, 79 by 21. Okay. Now you simplify this one, and now you have to calculate into weight ratio. Okay, on the mass basis. Okay, so when you are calculating mass, then you have to know this C molar mass 12, H 1, oxygen 16, hydrogen 1 and carbon oxygen, okay, nitrogen is there, nitrogen is 14. Now you put the values also. C2 means 2 into 12 plus H2, first one is acetylene, H2 means 2 into 1. So C2H2, this much of mass I have for 1 mole plus 2.5. Now how much mass is there? 16 into 2 plus O2, 2.5, 79 by 21. Now nitrogen 14 into 2 nitrogen. So right side also I'll have same balance. Right side will have like 2, 12 into oxygen 16 into 2 plus water 2 into 1 plus 16 H2O plus 2.5, 79 by 21 into nitrogen 28 nitrogen. So this equation gives 26 C2H2 plus 80 O2 plus 263 N2, 88 CO2 plus 18 H2O plus 263 N2. Okay, these are in kg. So you should not mistake assuming that this is a molar thing. This is we converted into kilogram. Okay. Now 1 kg of C2H2 implies, now the equation will be converted into like this, C2H2 I am dividing by 26 plus 80 by 26 O2 plus that nitrogen part, it will be, if I divide completely, then it will be like 263.3 nitrogen, 88 kg, no, 263.3 divided by 26, and this one will be 3.38, sorry, 88 divided by 26 CO2 plus 18 divided by 26 H2O plus 263.3 by 26 and 2. So this is my, for 1 kg of acetylene, how much amount of 1 kg. So all are kg actually. So I should write kg everywhere. Okay. So for 1 kg of fuel, if you burn, then how much fuel, how much air is needed? Now amount of air equals 80 by 26 plus 263.3 divided by 26. So it is giving 13.196 kg of air per kg of fuel or C2H2. Okay, hence the amount of theoretical power. This is theoretical. Okay, so if required, you can give higher amount or lower amount. So that is different story, we will calculate later. But actual amount is 13.196 kg of air you have to give. Now, if you have any organic compound or hydrocarbon and you want to go for a reaction, so one simple formula is that CXHY plus X Y by 4 O2 X CO2 plus Y by 2 H2O. Okay, if you have only air and you are reacting, so this will be the common balanced equation. So in that case, you have to find X and Y. If you do not know actual balanced equation, so you can use this formula. So CXHY plus X plus Y by 2 O2 plus 79 by 21, you can see again we are adding this one, X plus Y by 4 and 2 equals X CO2 plus Y by 2 H2O plus 79 by 21, again the X plus Y by 4 and 2. Okay. Now previous problem also you can apply and you can check whether this equation is valid. Now take one problem, question C7H6 with 10% extra air. Okay, then calculate mass of air supplied. Mass of extra air, mass of air supplied. Per kg of fuel. Solution, how can you do? like you can put this equation C6Hy, the previous, from there actually you can derive C7 CXHY plus XY by 4 equals not, I'll put arrow, X CO2 plus H2O Y by 2. Now X and Y value given here C7, so X equals 7, Y equals 6, then C7H6 plus X and Y value we put here, so 7 plus 6 by 4, 7 O2 CO2 plus 7 by 2 H2O. Okay, this is your balanced equation. Now you have given extra, so here it is not H6, it is H16. So it will be like this, HY16, so 16. So finally it is becoming X7H6 plus Y by 11 plus 11 O2, 7 CO2 plus 7 by 2 H2O. Now you have a nitrogen also. Okay, so what you can do like this, X7H16, okay, H16 X C7H16 plus 11. Now you can make O2 plus 79 by 21 N2, right side 7 CO2 plus 8 H2O, H2O will be Y by 2, no? So it will be 8 plus 11 O2 plus 79 by 21 N2. Okay. Now you have 10% excess here. Okay, so in that case your this constant becomes 12, 12.1, because 11 into 1.1, so it is becoming 12.1. So now air fill ratio A by F, air, how much air we are taking? 12.1, 12.1, oxygen 32 plus 79 by 21, nitrogen 28, and how much fuel is there? 7 carbon, 7 into 12 plus hydrogen 16 into 1. So this value is coming 16.6. So 16.6 kg of air needed to burn 1 kg fuel. Okay, so this is your solution. Now take another problem, propane. Okay, C3H8 with 10% deficient, deficient air. Okay, so then assume no hydrocarbon is produced, assume no hydrocarbon, no HC is produced and CO produced. Okay, so first you write down the equation C3H8 plus you do previously whatever. Okay, first you write down the equation and balanced equation. So 5O2, 3CO2 plus 4H2O. Okay, now you have to calculate volume of CO produced. Okay, now 10% deficit, 10% deficit. So the equation will be like this, C3H8 plus 4.5 O2. Why 4.5 A2? Because 5 atoms oxygen required, but you have actually 0.9%. So, it is coming 4.5. Okay. X amount of CO2 producing plus Y H2O producing plus Z CO producing. Okay. Now, for C balancing, carbon balancing you are doing. So, left side 3 equals X side, right side X amount plus Z amount. Okay. Now, for H, left side 8, right side HY into 2. So, Y becomes 4 and O 9 left side is there 4.5 into 2. So, it is 9 and right side equals 2x plus y 2y plus z. Okay. Now, 2x plus 2y plus y 2y 2x plus y, we have only one water right side in water. So, 2x plus y. So, if I write like this equals x plus z plus x plus 4 because equals x plus z equals 3 plus x plus z plus 4 actually x plus 4 3 plus 4 plus x, therefore, x becomes 2. Okay. Now, z equals you see from here actually 3 minus x equals 3 minus 2 equals 1. So, now the equation becomes C3H8 plus 4.5 O2 X CO2 plus Y H2O plus Z CO. Sorry, x value you have to put 2, y value I have to put y value I have got 4 and z is 1. So, no so CO means 1. Okay. Now, percent molar volume of CO2. CO carbon monoxide equals right side is 1 and right side total amount of mole is there 2 carbon dioxide plus 4 water plus 1 carbon monoxide. So, it is becoming 1 by 6 7. So, it is becoming 14.28%. 14.28%. Okay. So, this much amount of carbon monoxide is there. Now, another problem, CH4 is burnt with atmospheric air or CH4 or methane burnt with atmospheric air. The analysis of the product on dry basis is as follows: carbon dioxide 10%, oxygen 2.37%, carbon monoxide 5.53%, nitrogen 87.1%. So, you have to determine combustion equation, air fill ratio and theoretical air. So, first combustion equation. Combustion equation first you have to calculate or you have to establish. Okay. So, for that XCH4 plus YO2 plus ZN2, how much nitrogen we do not know first. So, 10 CO2 plus 0.53 CO plus 2.37 O2 plus a H2O plus 87.1 N2. Okay, this is on dry basis. So, to determine all the unknown coefficient, we have to balance this elements. So, nitrogen first. Okay. So, Z equals 87.1. Okay. Now, Z by Y 79 by 21. Okay. Therefore, Y equals 87.1 divided by 79 by 21. So, it is going 23.16. Now, carbon X equals 10 plus 0.53. You see right side 10 in carbon dioxide and carbon monoxide 0.53. So, it is becoming 10.53. And hydrogen hydrogen is giving A equals 2x. So, 2 into x means 10.53. So, it is becoming 21.06. So, this much amount of hydrogen is there. Now, oxygen balance. So, all the unknown coefficient have been solved for. Now, this oxygen you have to balance. Y equals 10 plus 0.53 divided by 2. You can see right side 10 is there, 0.53 CO, so divided by 2 plus 2.37 plus 21.06 by 2 plus this will be is giving actually 23.16. Already this value is coming here 16. Okay. Now if we divide both side by 10.53, then we get the equation CH4 plus 2.20 2 plus 8.27 N2 0.95 CO2 plus 0.05 CO plus 2H2O plus 0.225 O2 plus 8.27 N2. This is the answer. Now, air fill ratio. Okay. For air fill ratio on molar basis, total amount of mole of air. So, mole of air, if you see left side 2.2 oxygen, 2.2 oxygen plus 8.27 nitrogen is there. Okay. This is happening per kg of air. So, this is your air fill ratio equals 10.47 moles of air per kg of fuel. Okay. Now, the air fill ratio mass basis is found. Okay. Now, actual air fill ratio, the air fill ratio ideal condition CH4 plus 2O2 plus 79 by 21 nitrogen and 2 times, because or I can say like this. So, right side will be CO2 plus 2H2O plus 279 by 21 N2. So, this will give me my actual air fill ratio, the theoretical air fill ratio. This is theoretical. So, it will be like 2 then plus 2 into 79 by 21, 2 into 79 by 21 divided by okay, here I have to multiply 28.97 air mass, 28.97, that mass of air, 12 into 12 plus 1 into 4. Okay, this is fuel mass. So, it is becoming 17.24 kg air per kg fuel. Okay. So, this is your answer. Now, percentage of theoretical air, percent of equals 1896 divided by 1724 into 100 equals 110%. So, this is your answer. Now you will go for calculating a lower heating value. So lower heating value. So lower heating value of propane. So propane, you know, the formula is C3H8. Okay, you are burning with oxygen and it will be releasing heat. So heat also given. 25 degree centigrade, how much heat is getting released. Okay, now first you write down the equation C3H8 plus 5O2 3CO2 plus 4H2O. Okay, so higher heating value P or higher calorific value, in previous lecture I explained as a higher calorific value. Here in this book they are using higher heating value, the term. So both are same. LHV, lower heating value, plus MHFG, this enthalpy of phase change. Now mass equals 4 into 18, this water mass. Okay, water vapor. So 72 kg per mole. Now HFG is your latent heat or enthalpy. This is 2442 kJ per kg at 25 degrees centigrade. Okay, so HHV equals 2044009 plus 72 into 2442. So this is giving 2219833 kJ per kg. This is your answer. Now higher heating value. HHV constant HHV at constant volume equals HHP HHP constant pressure minus del nRT. Okay, so del U equals del H minus del N, number of moles, R O T. Now this, all the signs will be negative. Then HHV V equals HHP V suffix P plus del nROT. Okay, R is universal gas constant. Okay, this value is 8.3143 kJ per kg mole per K. So del N equals Np minus Nr. Np number of mole gaseous product and Nr is number of gaseous reactant. Okay, now the reaction is like C3H8 plus 5O2 3CO2 plus 4H2O, now liquid. Okay, now del N equals 3 minus 1 plus 5 equals minus 3. HV constant volume, so 2219833 minus 3 into 8.38143 into 25 plus 273. This is giving 221240 kJ per kg. Okay, this is your final answer. So calculate the lower and higher heating value of constant pressure per kg of mixture at 25 degrees centigrade. First I can make mixture of benzene and octane. Okay, now the value are given C6H6 kg per mole and this also given. Now first you have to calculate air and benzene vapor. Air and benzene. Okay, C6H6 gas plus 7.5 O2 gas, 7.5 79 by 21 nitrogen gas, 6 CO2 gas plus 3 H2O gas plus 7.5 79 by 21 N2 gas. Okay. So, since water is the product in vapor phase, so lower heating value becomes L H V suffix P equals 3169500 kJ per mole. Okay, so LHV constant V per kg of mixture equals 3169500, 12 into 6 plus 6 into 1 plus 75, 7.5 cross 32 plus 7.5 79 by 21 into 28. Okay, so this is giving value 2861 kJ per kg. Now HHV constant P equals LHV P plus M HFG. Okay. Now HFG equals 2442 kJ per kg at 25 C. Okay, so HHV suffix P equals 316950 plus 54 into 2442 is going 330 1368 kJ per kg, kJ per mole. Thus, a higher heating value, constant pressure is per kg of mixture, HHV per kg of mixture, kg of equals 3301368 divided by 78 plus 240 plus 790 is becoming 2980 kJ per kg. Okay. Now air and octane vapor. So you calculate similar way. Air and octane. Air and octane. So in that case, your equation becomes C8H18 gas plus 12.5 O2 gas, 8 CO2 gas plus 9 H2O gas plus 12.5 79 by 21 nitrogen gas. Okay, so left side also nitrogen should be there. Okay. Now in the same way you calculate and finally you get higher heating value, constant pressure 55 you get 3010 kJ per kg. So this one I left detailed calculation I left for you because it is same as your benzene calculation. So please try yourself. Now percentage of theoretical air use, percent of theoretical air, percent of theoretical equals it becomes like 159.48%. Okay, so just you calculate yourself that octane part. Benzene part I have done the calculation. Thank you very much for today's lecture. Next day we will start with a new topic. Thank you.